Welcome. In this video I'm going to show you how you can obtain frequency densities and using Python. I'm using a Jupyter notebook with Python version 3.818. Frequency densities are actually simply the frequency divided by a bin width. It shows how dense a specific bin actually is. To show you how this can be done with Python, I'll simply first load some example data by using pandas, so importing pandas, and then I can load a GSS, General Social Survey 2012, adjusted for example purposes. I actually don't need all the data from it, I just need one scale field, so one numeric field. I'm going to be using the age field. Unfortunately, though, there is an 89 or older, so I'm just going to replace those values with 90. Not sure why I chose 90, but it's just as example. And therefore then, once I've actually replaced all of those, I have just one field full of numbers. In a separate video, I'll show you how you can easily do this with my own library, but in this video, we're not going to be using any other libraries. So the first thing I'm going to do is I'm going to actually sort the whole field. And as I mentioned earlier, the frequency density is simply the frequency divided by the class width, which means we first actually need to know the frequencies. So we can actually just go over a whole range. So I actually can go for certain bins. So let me first actually, I have here over here the bins I want to use. So let's say 0 but under 20, 20 but under 25, etc. And then I can actually use here the number of categories, and then it's just going to go over each of them and simply show me how many cases there were in each of those bins. The class width is simply the upper bound minus the lower bound, so that's going to be fairly straightforward. And finally we can then just divide these two by each other, so the frequency divided by the class width. So I can do that in one go, and that gives me the frequency density. If you want the relative frequency density, then it's actually, you can simply say, well, I'm going to be using, did I have anywhere the sum of all n? So I can say the full sample size equals the sum of all my frequencies. And then I can simply say that the relative frequency density is the original frequency density. E divided by the sum of all for E in FDI. So that should give me the relative frequency densities. Alright, I hope this video was helpful, and thank you for watching.